Good morning, afternoon, or evening to everyone, and welcome to the seminar on How Does Europe Do It? So greetings to everyone, including those in Melbourne, Australia. I'm hosting from Canberra, Australia today. I would like to take this opportunity to acknowledge the traditional custodians of the lands that we currently reside in and pay respects to the peoples, lands, and cultures to which we continue to share our knowledge upon, including my own in Ngunnawal country, and those in Melbourne, who most of whom are on Wurundjeri land. My name is Patrick KIEN, and I'm a classroom teacher at Macquarie Primary School in Canberra. This year I'm teaching Year 3 and Year 4, who are roughly aged between 8 and 10. I'm currently studying my Masters of Education at the Melbourne Graduate School of Education at the University of Melbourne. I value mathematics and mathematics education for the overwhelming potential for creativity and how it can lead to understanding the world around us in a better capacity. I'm interested in building student and teacher motivation, and I strive to inspire others to enjoy mathematics in the way that I do. I'd like to introduce you to Caroline Blakely, who will be running the Q&A for this session.
Thanks, Patrick, and welcome to everybody. My name is Caroline, and I'm a classroom teacher and mathematics learning specialist at Wonthaggi North Primary School, which is in regional Victoria. I'm on Bunurong country. I teach 9 and 10-year-olds and also work with teams of teachers to support their mathematics teaching. I'm currently studying my Masters of Education at the University of Melbourne, specialising in assessment and pedagogy. I'm particularly interested in factors that affect student engagement and outcomes in education, including differentiation, social equity, mindset, and the use of rich tasks and formative assessment in mathematics classrooms. And I'm really looking forward to hearing our presenters speak today. So I'll hand over now to Patrick so he can speak about how today's webinar will run.
So just before we begin, I'd like to remind you that this session is recorded. The chat function is not really going to be used. However, we do have the Q&A function ready for you to use for questions, suggestions, and comments. I'll hand over back to Caroline to explain the Q&A function.
Okay, thanks, Patrick. So I'll be curating the Q&A session of the webinar. After all presenters have spoken, we will start the Q&A session. So please feel free to post any questions you may have during the presentations. Please also feel free to respond to other people's questions and comments, because we'd really like to encourage discussion and participation. If you post a question, can you please let me know which presenter or presenters you would like to answer your question? And also, if you would like to ask a question in a language other than English, please do so, and we trust that there will be someone in the audience who will be able to translate. So I'll just hand back to Patrick now to talk about tonight.
Thanks, Caroline. So a week ago, we heard from 3 panelists from Korea, Singapore, and Taiwan, who shared with us their opinions on how does East Asia do it, with their students' performance scores consistently leading the world. In contrast, today we focus on the topic, how does Europe do it? We're honored to have 3 panelists from Italy, Poland, and Turkey who graciously accepted our invitations to share their insights and experiences with us in the next hour. By it, today, we are emphasizing students' improvements in maths literacy, as shown in the last PISA 2018. And we want to draw our attention to the observation that 15 of the 24 economies in this category are located in Europe. So for this webinar, we'll be joined by Associate Professor Francesca MORSELLI from the University of Genoa in Italy, Professor Zbigniew MARCINIAK from the University of Warsaw in Poland, and Professor Yüksel DEDE from Gazi University in Turkey. Our first speaker for today is Associate Professor Francesca MORSELLI. Associate Professor MORSELLI obtained her PhD in mathematics at the University of Turin with a thesis on the culture of theorems at a university level. Since 2015, she is Associate Professor of Mathematics Education at the Department of Mathematics of the University of Genoa in Italy, where she works in pre-service and in-service teacher education programs. Her research focuses on argumentation and proof in mathematics, the interaction between affective and cognitive factors in the teaching and learning of mathematics, and the formative assessment in mathematics teaching. Please welcome Associate Professor Francesca MORSELLI.
Thank you for this welcome. Thank you. Welcome to everybody, and thank you very much for the invitation. I'm going to share my screen to present you the Italian way. Okay, can you hear me and can you see the slides? Okay, perfect. So, first of all, I have to do a sort of disclaimer. I'm very happy to have been invited into this panel. But as Patrick mentioned, standardized assessment is not my main focus of research. I'm a researcher in mathematics education, but I do not do research on worldwide or international assessment. So what I'm going to tell you today, to report today, is based on official documents at the international and national level, my direct knowledge, of course, of the Italian school system, and my experience as a teacher educator in Italy. Okay, just some small information concerning Italy. This is a rough schema of the educational system in Italy. So we may see that there is a preschool education, primary, secondary of first and second degree, and tertiary. And it is interesting to know that for preschool and primary, there is a generalist teacher with a master's degree. In the secondary school of first degree, there is a math and science teacher. This to say, teachers may teach mathematics even if they do not have a degree in mathematics, but they have in science. And in secondary of second degree, mathematics and physics is often taught together. So the mathematics teacher may have a degree in physics and the converse. Usually, we refer to preschool, primary school, and secondary of first degree, so up to grade 8, as the first cycle of instruction. While from 9 to 13 grade, this is the second cycle of instruction. So this is just to give some first information. Other interesting facts about the Italian school system. Italy is known because it has a very low state expenditure in terms of education. It is below the OECD average. Another information is that tertiary education is not so widespread, even if this data is increasing for the younger generations. Italy has the oldest teachers. I mean, it has the largest share of teachers over the age of 50. And this also means that there will be a sort of change of teachers in the next years. So this makes teacher education very important. And a sort of positive fact, pre-primary education is very, very widespread. And among the 3-5 years old, the enrollment rate is quite 100%, is 94%, which is very, very high. So this is just to give you some information. But I was, okay, this is already said for the teachers. The idea was to discuss a little bit about how Italy performed in the last PISA surveys. And as the schema shows, Italy started very, very well quite low in 2003, but it experienced a sort of good improvement from 2006 to 2018. And at the moment, the average score is in line with OECD in 2018. One must know that this is for mathematics, while for reading and science, for instance, the average score is still under the average of OECD. In 2018, in particular, 76% of Italian students reached at least level 2, and 10% Italian students reached at least level 5. So this is in line with the OECD. Oh, I'm sorry, I mixed the two acronyms, average. Okay, of course, we are from one side satisfied with this improvement, but there are some issues that still need to be addressed. In particular, if we look at the national data, we see many differences between the different regions of Italy. In particular, the north of Italy performs over the average, while the south of Italy is still under the average. And there is a real problem of gender gap between girls and boys. The reflection of today is concerns what happened between 2003 and 2018. I'm not allowed to establish clear causal links between what I'm going to tell you and the PISA results, but I can tell you what happened in the Italian school system in these last years. The first information is that starting from 2001, there was a sort of renewal movement concerning guidelines. The first proposals for the guidelines were arrived from a joint commission of the Ministry of Education and teachers and the Italian Mathematical Union. So mathematicians and mathematics educators really worked on the proposal of new guidelines that were called Mathematics for the Citizen. And they were proposals for the guidelines, proposals for the activities, and proposals for assessment, because they really wanted to give a whole proposal for teachers. And for the first time, there was an organization of contents in content domains and process domains. And among the processes, problem posing and problem solving, conjecture and argumentation, and measuring. And there was, for the first time, the idea of a mathematics laboratory, so an active construction of knowledge by means of laboratory activities. Patrick, please tell me if I am too long, because I can see the time, so okay. That was the first proposal. After, starting from 2012, there were the official new guidelines. The idea in these guidelines is that mathematics should be presented in two ways, both as an instrument to model the world and as a form of culture. It was explicitly stated that it is important to provide opportunity to develop a good attitude towards the discipline, a good attitude towards mathematics, still the idea of mathematics laboratory, and there was the clear establishment of competence goals, but only for the end of each cycle. So for the end of grade 5, of grade 8, of grade 13, which means that schools and teachers had the high freedom to organize their teaching sequences, provided that at the end, the students reached the goal. The content domains were, I would say, more or less similar to the PISA ones. And there was the indication of the key competencies that are representing argumentation, problem posing, and solving. At the same time, the ministry established INVALSI, which is a national system of standardized assessment. It runs since 2008. And at present, it works every year for all the students in Italy and for all these grades, so grade 2, 5, 8, 10, and 13. So each year there is this standardized assessment program. Invalsi framework, of course, is coherent with the national guidelines. So we have domains and dimensions that refer to knowing, problem solving, and argumentation. And what is interesting is that Invalsi items are developed jointly by researchers in mathematics education and teachers. So there is a sort of also of a teacher education program to run the Invalsi assessment. And of course, data from Invalsi assessment are carefully analyzed by the researchers, by my colleagues, researchers in mathematics education, in terms of a better understanding of the Italian system. Just to give you an idea, this is an item for grade 2. And so these refers to numbers and to the representations of numbers. And I underline that all these items are a little bit non-traditional in comparison with Italian textbooks, because, for instance, they are less procedural and more relational in a way. This is another example of item concerning problem solving in grade 2. I skip more, maybe and okay. No, I wanted to show you this because there was a huge reflection on how to access argumentation. And for instance, this is an example. So this is a problem solving activity. And I just show you the final task for the teacher, for the students, which is, do you agree or not with what Julia says? Yes, I agree because. No, I don't agree because. So it is an open-ended question. Finally, what happened during all this period, there was a lot of effort in teacher education programs at national level and explicitly linked, of course, to the national guidelines. One example is these kind of programs, which are the operative national programs that are explicitly addressed to those regions that low performed. So those parts of Italy that had low score in PISA or in Invalsi. And the idea was to provide teachers at first theoretical instruments to understand national assessment and international assessment, and to understand what worked for their students or not. Another very good teacher education program was Matabel, which was organized around the national guidelines, so around relations, numbers, geometry, and it was a sort of big community of practice of teachers who were encouraged to perform laboratory activities that were planned and already experimented by teachers. Okay, I think I can stop. I have no idea how much time I took because I speak very fast. I'm sorry. I am ready for any question, and I put also on my PowerPoint some references concerning national assessment and some work of research by my colleagues who work on Invalsi data.
Thank you very much, Associate Professor Francesca MORSELLI, for showing your insight into how we do. Our next speaker is Professor Zbigniew MARCINIAK, who is a professor at the Institute of Mathematics at the University of Warsaw in Poland. From 2010 to 2012, he held the post of Undersecretary of State in the Ministry of Science and Higher Education. At present, he is the president of the National Council of Science and Higher Education. Professor MARCINIAK has been a member of the mathematics expert group of the OECD PISA project continuously since 2002. He has been appointed the chair of the maths expert group for the PISA 2015 cycle. He is also the lead maths expert in the OECD PISA-D project, a version of PISA for developing countries. He is co-chair of the group for the PISA 2021 cycle. In 2013 to 2014, he served as an expert at the Brookings Institute in the Millions Learning Project. For his contribution to support mathematically talented students, he was conferred the Silver Cross of Merit and the Knight's Cross of the Order of Polonia Restituta. Please welcome Professor Zbigniew Marcinik.
Hello everybody. I thank you very much for inviting me to this meeting. I really appreciate that, and I will try shortly describe how Poland has what Poland has done to improve the results of PISA, the results of the learning outcomes in mathematics in the past years. You see, even though Europe is a small peninsula which fits nicely inside the Australian continent, it is very diversified concerning the education. So I don't know how to answer generally to the question how Europe does it, but I think that collecting the experiences of different countries can provide a very diversified answer, which can be used, parts of them can be used, I think, elsewhere. So first of all, the school system, excuse me, that's already a complication because the PISA outcomes that we know came from a system which is quite similar to the Italian system. That means 6 years of elementary school plus 3 years of lower secondary and 3 years of upper secondary. But recently our populist government has cancelled the lower secondary schools, and we came back to the system that I was trained in, that is 8 years of elementary and 4 years of upper secondary. That's it. Which comes up to the same number of years, but it's a different system. So we still don't know how this will influence the PISA results, but we have the results from the past, and I will tell you how we did the improvement. I was in charge in part of it because apart from the fact that I was a vice minister in higher education, in the previous 2 years, I've been a vice minister of general education, and then I was working on the new curriculum, national curriculum, which also had some influence on the improvement. So Poland started PISA tests in 2003, and in mathematics, we started with a result 495 points on average. And then there was a stagnation for many years. I mean, we couldn't move forward, and we could easily see the drawbacks of our students. I mean, they were quite good in routine tasks, which gave them this slightly below OECD average result, but they were completely lost in tasks when it demanded some reasoning or unexpected situations. So we thought we should repair that drawback, and in the curriculum, new national curriculum in 2008, we have introduced the same, very similar things that what you have seen from the talk of Francesca just a few minutes ago. So reasoning and argumentation, modeling, stuff like that. And it was not easy because teachers did not believe that this kind of mathematics is available to every student. But the PISA outcomes have shown and have helped a lot, because when we are showing examples of such items from the released pool, and we're telling that here our students are quite poor in this context, they say, well, no wonder it's hard. But then we say, but how come that students in Germany and Great Britain and Holland do much better? Are they smarter than our kids? Then they started thinking and said, maybe we need to make a change. Of course, writing down a change in curriculum doesn't change a thing in school system. That we know, paper is very patient, but we have national exams, not so often as in Italy. This just happened in the past. We had 3 of them, one at the end of each type of school, one at the end of the elementary school, one at the end of lower secondary school, and one at the end of upper secondary school, which is, by the way, the only entrance exam to higher education. So once you pass this exam, the results of this exam are the basis for admissions to higher education. So we have just changed the content of the exams. Of course, doing good preparation for that, I mean, announcing what new types of problems will be available there. We have put on the exams on every level items which starts with the words proof that something is true. But not, of course, not a very formal proof, say in the elementary school, but give some argument that something is true. And on the upper secondary level, these are already regular proofs of some small theorems in geometry or algebra. And what a surprise came that the kids love it. I mean, the reaction of students was very positive. On the internet after the exams, there were great discussions how nice it was to solve this kind of problem instead of this boring problem to calculate something or to measure something. So that was a very positive impulse. And so Poland in 2012, well, we could observe the first results of this change, and we jumped up to, I believe, 514 points on the PISA scale. Then in 2015, there was a slow drop because that happened to many countries because of the change of the format of the PISA test. It came to computers altogether. But in 2018, we were again at the same level, 516 points on the PISA scale for Poland, which is in Europe quite good. Only Estonia is better, and I think we should keep this position. Now, one more information which may be very important in this context, that who is teaching mathematics in Poland? I mean, apart from the first 3 grades in elementary school, the classes in mathematics are taught by people with master's degree in mathematics. I mean, you cannot be a teacher of mathematics in Poland in grades 4 and higher if you don't have a master's degree in mathematics, but not in mathematics education, but just in mathematics, which means you have to take all these tough courses which come in this. Of course, on top of that, you get this preparation for becoming a teacher. I mean, all these didactics courses and methodology and psychology and pedagogy that is on top of this. But you have to first to pass this very tough learning of higher mathematics, and the same concerns all other subjects. That means if you want to be a teacher of physics, you have to have a master's degree in physics. It's very rarely that you connect the teaching of physics and mathematics, but rather physics and chemistry that happens more often. So this is a big advantage, I think. So when we introduced these new types of problems, the teachers had no difficulty with understanding how to do it. We didn't have to train them for that. The only thing that they had difficulty with was to believe that students can do this. But as we could see, it go on. So these national exams have, of course, because the objective of every teacher, parent, student is to get a good result at the exam. So these kinds of problems, which require mathematical reasoning, have, of course, came into the school programs and also to the textbooks and all support materials, and now a normal and very natural thing. One could say that this is just teaching to exam, which has bad reputation with some people, but I think the issue is more complicated. Teaching to a stupid exam is stupid, but teaching to a good exam is good. The exam is good if the students are able or asked to do things that develop their thinking. And in the past, I couldn't imagine a situation that you give on an exam something that students haven't seen before in some textbook. Now it's a norm. Each year there's a problem I am talking about the level of 15-year-olds, like the PISA exam, that no textbook contains an example of such problem. I remember one exactly, which is so easy I can describe it orally. You take a cube, and from each corner of this, from each of the 8 corners of the cube, you remove a small subcube. Yes, and you ask what is the surface area of this body. Now, of course, it didn't change. Yes, because what was outside is now inside. And there were beautiful comments of students. One of them was like this: I was calculating like crazy, but it was enough to think. I mean, and if you just justify that the number of small squares that you see is the same as on the outside as on the inside, that was a perfect score. So they said more of such problems in our classes, and in fact is going on. So I think this this is the more or less the picture that we have, and the results in the other two areas in reading and in science also stay on a very approximate level as the results in mathematics, because I was in charge of the whole curriculum and I was talking about mathematics here only, but in science we also introduced a lot of reasoning, scientific reasoning. So the kids have to imagine what would happen if something was changing in the physical situation or biological situation. They have to design experiments on that, and we got for that the credit in the PISA. And last thing that I would like to mention is that, in fact, PISA 2021 is shifting slightly more towards mathematical reasoning and argumentation. If you have read the new framework, that's very clear that a quarter of all items has to deal with this issue, because in the opinion of the math expert group, now mathematical reasoning and argumentation is really this part of math education from which students will profit more in the future life. The routines that we spent a lot of time on in the past are more often performed by machines. So it's better to devote more time to understanding what you are doing, to consider situations when you have to make decisions or to design what you will do. So that's the general direction of PISA, but also the direction in Polish math education. I will be very happy to answer any questions you have, and I think I should stop at this moment. Thank you.
Thank you very much, Professor Marciniak, for your insight into how Poland does it. I did find it interesting that the minimum for teachers is a master's to teach above year 4. I found that quite interesting, and I liked your statement about teaching to a good exam is good, but teaching to a bad exam can have some pretty bad effects too. So that was our final speaker for this webinar is Professor Yüksel DEDE. Professor Yüksel DEDE is a professor at the Department of Mathematics Education at Gazi University in Turkey. He has worked at Berlin Free University in Germany with the support of the Alexander von Humboldt Scholarship and Scientific and Technological Research Council of Turkey Scholarship, respectively. He has worked as a director, expert, or consultant in projects supported by various public institutions in Turkey and abroad. His research interests include teaching of mathematics concepts, teacher education, effective aspects of mathematics education, values in maths education, mathematical modeling, international comparative studies, research methods and applications of advanced statistical techniques in mathematics education. Please welcome Professor Yüksel DEDE.
Hello, everyone. Thank you for giving me this opportunity. In this Zoom meeting, being the last speaker is always hard. I hope that due to COVID-19 pandemic, these difficult days will be over as soon as possible. First, I want to show you the main titles of my presentation. The presentation will be accordingly. Firstly, about I will mention about Turkey and Turkish student PISA result, and innovation and updates in mathematics education in Turkey. These titles contains 5 subtitles. You can, as you can see from the screen, curriculum, high school entrance exam project, and information and communication technology investments, and supporting and training courses. Finally, Education Vision 2023. Firstly, I want to say there, Turkey as a candidate country of the European Union. And as you can see from the map, Turkey is a bridge between Europe and Asia. Due to its location surrounded by the sea on three sides, Turkey has always been the center of great trade, silk and spice routes. Today, Turkey is a country of different cultures, beliefs, ideas, nature, and history. As seen figures, according to Hofstede's cultural values, Turkish society has a collectivist view, a high power distance index, and high levels uncertainty avoidance index. In consideration of these results, the reflection of these values on classroom practice in Turkey are expected to lead to teacher-centered approaches. Also, to better see what this data means, if we randomly take a country from Asia, like Taiwan, and a country from Europe, like Netherlands, and compare the cultural values of those countries with Turkey. Turkey shows more similarities to Asian countries like Taiwan than European countries like Netherlands. Of course, this data can be different for different European and Asian countries. I want to talk about education system to Turkey briefly. In 1997, compulsory education was extended to 8 years from 5 in Turkey. The first 5 years in this period are called the primary school, and the next 3 years are called the middle school. In 2012, compulsory education was again extended from 8 to 12 years, and the education system was arranged as 4+4+4. In the system, the first 4 years were named as primary school, and second 4 years were named as middle school, and the third 4 years were called high school. Looking at the figure, the primary school education is between age of 3 and 6 for children. Also, the primary education age covers children of 6 to 14 years old. Students who have completed their 8-year education attend compulsory high school. Thought of different types of schools. High schools education is broadly split into 2 main school types. These are general secondary education, such as Anatolian education, science education, etc., and vocational and technical secondary education. At this point, I can see this. PISA exams in Turkey are attended by grade 8 and grade 9 students. I want to talk about now my second tiles, Turkish students PISA results. As you can see from the figure, although Turkish students' mathematics achievements have increased according to the results of PISA studies conducted in the past years, except for 2015, they are still lower than those of students in other countries. In detail, for example, PISA 2018 results show that Turkey has increased significantly its score in all 3 disciplines, reading, mathematics, and science, as you know. Not only Turkish ranking has also risen, but also Turkey's average math score is the high level since 2003. Also, Turkey has been the country, one of the most increased their scores in PISA 2018. Of course, these results, as you can from the screen, these results are not enough. Therefore, especially for the last 20 years, various updates have been made in the context of mathematics education in Turkey to bring these results to the desired level. I would like to talk about some of these developments and updates in this point of my speech. At this point, I have collected these developments and updates in 5 major headings. Of course, other titles may be added here. These titles are curriculum, change of high school entrance exams, project and information and communication technology, ICT, etc. Now let's talk briefly about these titles in order. My first title, curriculum, change of curriculum. I'll also address the update studies in Turkish mathematics curriculum under 2 main titles. These are compulsory education curriculum from primary to high school level, includes this, and mathematics teacher curriculum. You can see from the extra screen, revision of mathematics curriculum, compulsory education. The updating mathematics curriculum based on student-centered teaching approaches has started in 2005, and it is still in progress until 2018. In this context, mathematics curriculums have been prepared by focusing on critical thinking, creative thinking, and using technology, etc. And especially they focus on the development of mathematical process skills such as problem solving, connection, communication, math modeling, etc. Also, the curriculum, they have been updated to give more importance to the role of knowledge in daily life. The second curriculum change, mathematics teacher program, the updating curriculum of faculties of education based on student-centered approaches has started in 1997 and continued in successful years till 2018, like compulsory education curriculum. The second subsidies in examination. Since 2000, different exams have been applied in different content for the requirement of students to high school, Turkish high schools. Now I am going to talk about the last 2 types of exams to show the differentiation in questions. These are exams transition from primary education, secondary education, TAOG, in Turkish we say it TEOG, and high school entrance system, LGS, we say it Turkish LGS. TEOG has started to be implemented since 2013. Also, LGS has been introduced in place of TEOG exam since 2000, I remember, 7, and it is still going on. As you can see from the screen, a sample of TEOG 2015 exam items. As this question shows, there is only a simple process, and it asks about the value of A. There are more examples on TEOG exams. Of course, there are some questions that measure high-level cognitive skills, but there are a few of them. Considering PISA exam questions, it can be seen that Turkish students are not familiar with PISA questions in this context, in this Tiong exam. Other exams, LGS, LGS exam, you can see LGS exams items. These questions measure more high-level cognitive skills and is partly similar to PISA questions. That's the level of almost all the questions on the LGSE exam. My title is, my third title is Project and Information and Communication Technology Investment in Turkey. At this point, I will talk about two very important projects, Turkish Ministry of Education. In Turkish, we say it MEP. The first is the monitoring and evaluation and academic skills. In Turkish, ABIDA, we say it ABIDE. This exam called National PISA. The other is project movement and enhancement opportunity and improving technology. In Turkish, we say it Fatih project. ABIDE is MEP's project to monitor and evaluate the development of students. With the ABIDE projects, Turkish Ministry of Education target to determine the levels of students with high-level cognitive characters by using different types of questions. As a result, it plans to establish a monitoring evaluation system at the Turkish national level. Now there is an example of these questions. I did not translate into Turkish because very long, it is long. The question is, does it offer a scenario based on the films shown in 4 cinemas and the start time of those films? It's designing a table that is appropriate for this scenario. And then according to this table, 3 independent questions are asked. Like these questions in ABIDE measure also more high-level cognitive skills and is partly similar to PISA questions. And since 2010, Fatih project is education has launched with the proposal of providing equal opportunities in education and improving the technology in schools using information technology to engage more sense in the educational process. One of the most important components of Fatih project is the education information network. In Turkish, ABA, we say it EBA. We say it named EBA. EBA system is used in only teaching. With the Fatih project in education, students are able to access to course, notes, classroom project, and homework that are assigned by teacher. As you can see from the screen EBA education system on page example. You can see from the screen, student can access the lessons, mathematics, Turkish cognitive skills, and Turkish teaching for foreigners, etc. on EBA system. Okay. The other example, this is an example of an EBA teacher page. On the left, there are buttons for access to exams, classes, library, etc. The current screen shows the contents of a library of teachers. Here, there are also the contents of system application, etc. After curriculums, exams, and projects, EBA, Fatih projects, ABIDE, we came to other major headings. supporting and training courses. Since 2015, support and training courses, especially mathematics, have been opened in formal education schools by the Turkish Ministry of Education. These are lessons open to support and train willing students, and they are usually held on weekends and free. Finally, last main title is the 2023 Education Vision. In 2018, Turkey has put forward 5-year goals related to education. These goals have been reported under the 2023 vision. The main purpose of the vision is to raise science-loving, skilled, and ethical individuals who take an interest in culture and are willing to use present and future skills for the well-being of humanity. The vision contains a lot of statements that will quite this and many other points like this. Suggested reference you can see. Thank you for listening.
Thank you. Thanks very much. So thank you to all our panelists for sharing their knowledge with us. We've had a lot of good questions come in. Now I have some questions that are targeted to individual presenters, and then I have some more general questions. But the first question is for Professor MORSELLI. Could you please tell us more about the maths laboratory that you spoke about, what it looks like, and how does the national guidelines describe how it should be used by teachers, please?
Yeah, thank you. Okay, the idea of mathematics laboratory that is described in the national guidelines, and it also theorized by the research in mathematics education, is that it is not necessarily a separate place. I mean, it is not like ICT lab with a physical place where students are led to do some special activities. It is a sort of methodology where when students are led to be active in their math activity. So it can also be linked to a sort of inquiry-based learning. And the idea is that students, for instance, working groups, after they have a discussion where the teacher orchestrates this discussion to move them towards a construction of meaning. So it is not necessary that they work in a separate place or with instruments, but it is the way of working that is important. Of course, special examples of a mathematical laboratory are works with artifacts such as dynamic geometric softwares or abacus or other kind of mathematical artifacts. But it is not the fact that there is an artifact, but the kind of activity that you do with this artifact.
Okay, thank you. Thanks. The next question is for Professor MARCINIAK. You spoke about the very high standards for becoming mathematics teachers in Poland. We had a few questions about this. Do you have enough teachers? Do you find there are any supply issues when finding teachers for lower level maths classes? So it's possibly two questions.
Okay, I must admit there's one disadvantage in our system of requirements for becoming a teacher. If the salaries stay low, they get hundreds of opportunities to work elsewhere with their education. But that's of course a danger, but we don't we don't have a lack of teachers. It's a quite good job, and also somehow manage. One reason is that it has been so for years. It's not a new system. So just part of the people who graduate from the mathematical departments pick this path of professional path, and that's it. And some of them move after some years somewhere else. Some of them love the job and stay. And it's we don't have any special issues with providing enough teachers. I think that's our luck that we have designed. One plain advantage, I don't know how it's in other countries, for sure it's not common, but in Poland, so that students, the alternative is to pick pedagogical studies and then to go to the profession of a teacher of mathematics. It happens so in many countries. Also in some very high achieving countries in PISA, like in Canada, for example. The only way to the profession of a teacher of mathematics is to go to a pedagogical study and specialize in mathematics. But in Poland, it's so that that's a set circumstance, but I have to admit it sincerely, because the information should be sincere, that the level of students who apply to pedagogical studies is much lower than the level of students who apply to studies like mathematics, physics, chemistry, or even Polish language. So you require much more of those students. They are on the entrance better. So finally, when they graduate, they also are better prepared, more intelligent. I don't know. We have to do something with our pedagogical studies. That means we have a problem here, but that's because the pedagogical science in Poland is quite weak. I mean, it's hardly international. We have a big problem here. If we improve that, maybe we could build an alternative path, but that's my answer to the question.
Thank you very much. Professor DEDE, you spoke about in Turkey regular curriculum changes have occurred, and the question is, have the regular curriculum changes affected cultures within the school, within your schools? Do you want me to rephrase it, or you're on mute? Oh, down on the bottom left-hand side.
Okay.
You're done. Do you want me to repeat the question?
Yeah, Turkish curriculum in Turkish setting has been updated, especially the cognitive skills, as well as, of course, effective dimensions. For example, especially these are updated beliefs and values, and I contribute especially in terms of values and beliefs. Curriculum aims to develop students' attitudes and enjoyment of mathematics. In PISA results, Turkish students like mathematics. This data, I think, for this, I hope for this, it is useful. We need to make a curriculum and applying teaching methods, in this, so we make necessary updating on mathematics education. I hope it will be better on the next future. Yeah, okay.
Okay, because you spoke about the curriculum becoming more about real life for the students, reflecting the students' lives. So the curriculum is more engaging for your students. Oh, you're on mute again. That's okay.
Huh? Okay.
Yes.
Okay. I hear now. Sorry. Yeah. Of course, this curriculum has affected by, as you know, only curriculum changes of only curriculum. You don't expect suddenly students' achievement and attitudes. I think this updating of curriculums is slowly on students better. Only we strongly urge, strongly advise and apply to Turkish schools, especially for this Turkish students' exams have affected of Turkish education system. As I mentioned on my presentation, Tiong and MGSE student exam entering exam high school students have effective of mathematics perspective. They may see on mathematics now as a connection life, daily life and cognitive levels. Okay, thanks.
Thank you. Thanks for that. The next question, I'm not sure how we're going for time, but the next question was a question that we asked our panellists last week. So I'd like to ask it to each of you. And it was really just how has COVID-19 affected mathematics teaching in your country? How have you approached it? So I'm not sure who would like to start. Maybe Professor MORSELLI, would you like to start? That's it.
I'm sorry. I'm sorry. Could you repeat your question, Caroline?
Okay, the question is just, how has COVID-19 affected mathematics teaching in your country? How has COVID-19 affected mathematics teaching in your country?
A lot. Okay, a lot, I think, in terms of organization. I mean, we spent all the spring in lockdown, as you know. So there was distance teaching, and I can say that our teachers were not at all prepared for distance teaching in terms of use of technology and also of change of method. So they were very, very touched by this. And they realized that there are some important features of their teaching that it is very difficult to realize in distance teaching. For instance, the interaction with students or the laboratory activity. So most teachers reported that they had to give up on these features of their teaching.
Okay.
And also now we are in a sort of mixed situation because they are back in school, but with distance, safety, and so they still report that it is not exactly the usual way of doing mathematics.
Okay, thank you. Professor MARCINIAK, would you like to answer the question?
Yes, yes, it's well, of course, teaching of mathematics has been affected in the same way as of teaching of other subjects, but there's one small thing that I would like to mention. There's one advantage, namely, when I talk to teachers of mathematics, they say that on everyday news in TV, they got beautiful examples of stupidity of the newsmen who provide false information. It's not that it's invalid, but it's put in bad context. For example, they show how many people have been infected in the US, Brazil, and Poland last night, without referring to the size of the population of these countries and stuff like that. They report how many people have died today of COVID, but don't say how many people have died in general today in Poland, so on. So these are beautiful examples of teaching, can be used in teaching of mathematics to realize how you can falsify the data to create impression that you have big news. And it's used by the teachers of mathematics in the COVID times. Thank you.
Thank you. Professor DEDE, would you like to contribute?
Yeah, thanks. In Turkey, the COVID-19 epidemics affects and reshapes education as well as affects all sectors. Formal education, I want to remember this data. Formal education was paused for a week in schools or Turkey due to COVID-19 pandemic on 16 March. Okay, I remember. And distance education started on after 1 week, 23 March. Distance education has started for more than 80 million Turkish students at primary, secondary, and high school level. You can see Turkey have a lot of people from primary to high school, about 80 million students. New state in this process are 3 new state television channels. These are Turkish Radio and Television Institute. We say it TRT, TRT, EBA TV Primary School. I mentioned about my presentation early, and TRT EBA TV Secondary School, and last TRT EBA TV High School, and also Education Information Network, that is EBA. On television canals are opened continuously for primary, secondary, and high school education, separate the levels. About, I remember, 25 minutes of lesson rebroadcast at all grade levels, continue until evening hours, and it is going on. In addition, in Turkey, 3 major global systems for mobile communication, GSM operators in Turkey, provide free internet service for all students and their parents. However, there are still problems due to lack of internet, economic problems of some families, etc. Nowadays, therefore, Turkish Ministry of Education has started distributing free tables to students. Okay, thanks.
Thank you. Just need to ask you, Patrick, do we have time for any more, or is that it for questions?
I think it's up to E.
Okay. So, well, I might just thank everybody. Do we have more time, or is that's time, isn't it? Yes. Yeah. Okay, so I'd just like to thank everybody for sharing today. It's been wonderful, and thanks to Tiong for organising the webinar, and I'll hand over to you now,
Thank you, Caroline. My name is Tiong Seah from the Melbourne Graduate School of Education, who is currently feeling very proud for the 4 of my 30+ talented Masters of Education students who have just hosted an international webinar for the first time last week and today. Whether it is the Eurovision Song Contest or the Euro Cup soccer tournament, only one winner is normally acknowledged. What is empowering about most of the international maths assessment exercises, such as TIMSS and PISA, is that there can be many winners as different education systems interpret the objectives of maths learning and of school education differently. So, for example, not all maths education systems might want to be in the top spots in PISA or TIMSS, and nor should they be. So while we heard from the 3 panelists last week about their views on how the mathematics education systems consistently led the world in the rankings, we have been privileged today to have also learned from our 3 panelists from Italy, Poland, and Turkey on how their students demonstrated improvements in their latest PISA scores. And of course, there are several other interpretations of improvements which make other countries winners too, such as an increase in the proportion of students who achieve higher levels of mathematics proficiency. So in this context, I invite you to think about both the sessions by referring to the YouTube recordings if needed, not only to consider what are distinctive about East Asia and about Europe, what are distinctive between East Asia and Europe, but also what are different within East Asia and within Europe, as well as the synergies across these 2 regions. So this way we can all be winners too, as our experiences in the successive cycles of TIMSS and PISA contribute to more meaningful student learning of related mathematical knowledge, skills, attitudes, and values. So all this would not have been possible today had it not been for our panelists and our graduate student hosts. So I would like to take this opportunity to thank Caroline Blakely, Professor Yüksel DEDE, Associate Professor Zbigniew, Patrick KIEN, Ashley Koo, Professor Zbigniew MARCINIAK, Associate Professor Francesca MORSELLI, Professor Jong-Suk Pang, Will Su, and last but certainly not least, Associate Professor Ting Wang, for their generous sharing of the time and experience for the 6 panelists, and to the 4 graduate students for being game to try your hands at hosting a webinar for the first time. Last but not least, thanks to all of you attendees for your participation and contribution to the online questions and discussions. We may not have the time to answer all the questions today, but they will be passed on to the panelists, and we will make this available if the opportunities arise. So may you all thrive in your respective maths education studies, research, work, and teachings wherever you are. Stay well, stay safe, and stay connected. Thank you very much.
Thank you.
Thank you.